Alex is a beekeeper and has noticed that some of the bees are very sleepy. She takes a random sample of 320 bees and finds that 15 of them are indeed so-called lullabies that fall asleep easily. Calculate the sample proportion of lullabies. Well, our P is just going to be 15 out of 320, which is 0.046875. Might be easier to use the 15 over 320. Determine a 90% confidence interval for the true proportion of lullabies rounded to 4 decimal places. Well, we've seen Z90 before in this paper, 1.6449, and we've seen how to do the confidence interval. So it would be 15 over 320, take away 1.6449 times the square root of 15 over 320 times 320 take away 15 is 305 over 320 over 320, and then the 15 over 320 plus that, plus the same thing. And you could calculate that, but we'll probably just use the activity. Let's just quickly grab that again. It would be, we're actually in that one because it was the last thing we used here. So what did she have? 15 out of 320? And she's doing a 90% confidence interval, make that 0.9. Execute that, and you can see we get 0.0274 and 0.06333. I always think it's worth showing this calculation because we've got 3 marks here. What is the margin of error in the above estimate? Well, 0.0274 to 0.0633, half of that is the margin of error. So we can just do 0.0663, take away 0.0274 and divide it by 2, and we get 0.01945. It turns out that the true proportion of lullabies is 0.02. Now that Alex knows this, she decides to take a new sample. Suppose a new sample of 290 bees was taken. Given that the true proportion of lullabies is 0.02, what is the probability the sample proportion in this new sample is at most 0.03? So, we have a normal with 0.02 as the mean, and that would mean the variance is 0.02 times 0.98 divided by 290. And that is a normal 0.02, 0.0000676. And remember that the standard deviation is the square root of that number. And we want the probability of x being less than 0.03. That is just going to be a normal CDF on the calculator. You should have done that hundreds of times. It will give you 0.8881. If Alex takes a larger sample, will the above probability increase or decrease? Explain. Well, it's going to increase, and the reason for that is when you have a larger sample, you get a smaller standard deviation. So more of the values will be closer to the mean value, which is included in this interval. And we know about the larger sample because it's in the denominator just here. So a bigger number there is going to make the standard deviation smaller.